Welcome students to the chapter Haloalkanes and Haloarenes of class 12. In this part, this is part 8, and in this part what we are going to see is preparation of haloalkanes. And the preparation, as we have shown, as we saw in the last part, you can prepare it from different materials, different starting materials. Here in this part what we are going to concentrate is on its preparation from alcohol, and that too using halogen acids like hydrochloric acid, hydrobromic acid. So how to prepare using these halogen acids? Haloalkanes preparation from alcohols, how to do it? This is what we are going to see. So first we will see the last slide which we saw in the previous. So preparation of haloalkanes and haloarenes. Three methods I can use. I can synthesize haloalkanes from alkanes, that is hydrocarbons. So first one is to prepare from hydrocarbons. From hydrocarbons, if this H is removed and if I substitute that with a halide, then I will get a haloalkane. In the second method, I can synthesize it from alkene. So what is alkene? It contains double bond. So if I break this double bond, I can add atom to this carbon and to this carbon. If I break this double bond, I can add atom into this carbon and this carbon. So you can see it here. I am adding H here and I am adding X here. So since it's an adding process, we call it as addition reaction. So here what I am getting is, what I did is, I have added X here and I have added H here. So it is monohaloalkane. I can also add, I can cut this bond and add X onto both carbon. So I will get dihalo. In general, I can call it as polyhaloalkanes. Clear? And the last one is the substitution reaction. In this substitution, what I am doing, the starting material is alcohol. So I am taking alcohol and I am adding some reagents and I am removing this OH, or I am replacing this OH with X. Clear? And in the case of arenes also I am doing the same. So from alcohols, I am substituting X. So I am substituting X instead of OH. So I am removing OH and I am adding. This is what we are going to see in this part. So substitution reaction from alcohols. So there are different ways of substitution. In this part we will see only one way. So let us see what are the different ways for substituting OH with X. So from alcohols, as I said just now from the previous slide, OH is replaced with X. So for this replacement, what are the various reagents? What are the various conditions? So I have to get an answer. What must be filled here? So there are three main types of reagents that are used to replace OH with X. So as far as a reagent is concerned, there are three main types. What are they? Concentrated halogen acids. So halogen acid, or you can call it as hydrohalic acid, like hydrochloric acid, like HCl, HF, HBr, HA. So all these concentrate halogen acids can be used as a reagent to replace OH to X. Or I can use phosphorus halides, either PX5 or PX3, or even a raw substance to create this inside the test tube. So red phosphorus and X2 on heating. X2 means any halogen element on heating will give either of these two compounds instantaneously. So I can use any of these phosphorus halides in order to introduce X into, or replace X with OH. Another important reagent is thionyl chloride. thionyl chloride's importance is that you will get pure RX, which we will see later. So in this part we are going to concentrate on concentrated halogen acids. So I can use this as a reagent, but what are the conditions? So this is what I am going to see. What are the conditions, and what concentrated on what concentration should I use this? These are the things I must fill here. This is what I am going to see in this part. So from alcohols using concentrated halogen acids. So how I am going to convert alcohols into haloalkanes. So I have alcohol here. Let us see, there are at least 5 or 6 ways to convert it. So let us see one by one. In the first case, if I am passing HCl gas through this alcohol, HCl gas, what happens? So this H here, no, it will take away OH. If H and OH is combining, you will get H2O, HOH, or you can call it as H2O. So what is remaining then? R and Cl is remaining. They will combine to give RCl. Clear? So HCl in this Cl will replace OH. So passing HCl gas, on passing HCl gas, what happens? Cl will replace. Or instead of passing HCl gas, what I can do is I can heat alcohol with concentrated HCl. So my purpose is to replace this. So the source is here, we have learned this concentrated acid. So either you can pass HCl gas, because HCl is generally found as fumes, and concentrated HCl is that this gas is passed through water. Clear? So when it passed through water, we already have water there. So to make the condition severe, I'm heating it. So I'm heating with concentrated HCl. So Cl will replace OH and I will get haloalkanes. Or instead of heating, I can use catalyst. So what is the catalyst? Zinc chloride is the catalyst. So this catalyst will help to replace Cl from OH. So OH is replaced by, so this is gone and Cl will take its place. So RCl plus H2O. Clear? And this combination HCl plus zinc chloride catalyst is called Lucas reagent. Lucas reagent, which we will see in detail in the coming slides. Okay, so in all these cases, what I am getting is chloroalkane. So what I am getting is chloroalkane. Passing HCl gas, which means that there is only HCl molecules there, or passing or adding constant HCl and heating, or instead of heating I am adding zinc chloride as catalyst. So in all these cases, what I will get is chloroalkane. Now what if I want to get bromine? So I am heating it with 48% HBr. 48%. I require only 48% because this is more stronger acid than HCl. HBr is more stronger acid than HCl. So I will get RBr. Or what I can do is I can add salt of Br and H2SO4. So in the previous classes we have learned that whenever I am adding a salt along with H2SO4, H2SO4 is able to generate the acid of this anion. So what is the acid of anion? HBr, which we have seen here. So H2SO4 will help Br to generate its acid, that is HBr is generated here. If a salt and H2SO4 is mixed, H2SO4 will help to generate or form the acid of that salt, that is HBr. So I will get a similar result. I will get the substituted product of bromoalkane. So this is how to get bromoalkane. Now how to get iodoalkane? Here I am using much more weaker acid, 95% orthophosphoric acid or simply phosphoric acid. So this acid is called phosphoric acid or orthophosphoric acid. Clear? So it's 95% is taken. So you can either take sodium iodide or you can take potassium iodide. Here I have taken a NaBr. You can also take maybe potassium bromide. So I can take this and mix with 95% of phosphoric acid. I will get Ri. So why I am not using H2SO4 here? That's a question which we will see in the coming slides. So using this method, I have generated three types of halides. One is chloride, the other one is bromide, and the other one is iodide. So one is missing, which is that fluoride is missing. I cannot generate fluoride by this method. Directly I cannot generate, which we will see why. The reason for that in the coming slides. Okay, so once again recollecting, I can specifically change alcohol into corresponding haloalkanes. How? If I want chlorine as halo group, pass HCl gas or heat it with constant HCl, or avoid heating by using zinc chloride as the catalyst, which is called, this combination is called a Lucas reagent. In order to get Br, you reduce the acid strength 48% HBr, or use combination of salt and H2SO4. H2SO4 will generate the acid of Br here, HBr. The next is again reduce the strength of the acid that is supplied, that is 95% of phosphoric acid or orthophosphoric acid along with either potassium iodide or sodium iodide. You will get this compound. So these are the reactions that must be by hearted. Okay, so we will move on to the next part, next slide. So here, preparing fluoroalkane RF from alcohol using the halogen acid of fluorine, hydrofluoric acid, is not possible. Why? So this is not possible. I will write it. So ROH giving RF using HF is not possible. This will not work. Why is it so? Remember is that among all the hydrohalic acids or among all the halogen acids, HF is the weakest acid and HI is the strongest acid. In order to replace OH from ROH, the acid must be strong. Clear? So in order to replace OH minus from ROH, the acid must be strong. So this is a weak acid. So that's the reason. HF is the weakest among all the acids and hence difficult to replace OH minus. So among all the hydrohalic acids, HF is the weakest. So it is difficult to replace OH minus from ROH for this acid. Clear? Now next. In the reaction between NaI and alcohol, to synthesize iodoalkane, we have seen that, isn't it? So to alcohol what I added was NaI plus 95% orthophosphoric acid, and I did not use sulfuric acid in that case. In the case of iodoalkane, I did not use sulfuric acid. Instead of that, I used 95% orthophosphoric acid. What is the reason? So if I am using sulfuric acid, so let us write it here. If I am using sulfuric acid, I have NaI. Then if imagine that I am using sulfuric acid instead of phosphoric, so H2SO4. So as I said in the last part, whenever acid is mixed with a salt, it will immediately give its acid. So what will be the acid what is the acid that we will get? That is HI. And HI is a strong acid. Immediately when the HI is formed, since it is very strong acid, it will again react with H2SO4. HI will react with H2SO4. H2SO4 is a good oxidizing agent. Not that best like HNO3, but still it is a good oxidizing agent. So this is a strong acid and we have a good oxidizing agent. So the strong oxidizing agent will immediately convert HI into I2. Immediately convert HI. This will be converted into I2. Who will do this? H2SO4 will convert HI into I2. So what is required for substitution here? It is HI. And H2SO4, though it will give HI, but he again will convert that HI into I2. So I2 cannot do the substitution. What substitution? ROH to RI, isn't it? Alcohol into RI. For that I need HI, but HI is being removed by H2SO4. So to convert ROH to RI, we need HI. But HI formed will be removed by H2SO4 from the reaction as I2. HI is formed if I am adding sulfuric acid, but it will be removed by sulfuric acid from the reaction as I2. So this is the explanation given here. NaI with H2SO4 gives the strongest hydrohalic acid HI. HI formed will be oxidized immediately to I2 by H2SO4. So what I need is HI, but sulfuric acid will remove that HI. Clear? So next question is, what is the order of reactivity of alcohols? Order of reactivity of alcohols with the given hydrohalic acid, halogen acid. So an halogen acid given, what will be the reactivity of order of reactivity of alcohols? So what we should know is, what are the different types of alcohols? Like halides, so I will write it. I have three types of alcohols. So in the halides I have learned that I have primary, secondary and tertiary. So how will the primary look like? So it will look like this. So it has two, so the X is attached, the halogen group is attached to a carbon that is attached to another carbon. So it has only one CC bond on it. Such carbon is called primary. Now what is secondary carbon? So I will again draw it. So I have CH and I have one C here and one C here, and I have an X here. So this carbon is called secondary. And if halide is attached to the secondary carbon, the entire halide is called secondary halide. Now what is tertiary? We have already seen C. It has another C attached to it. So there are total of 3 CC bonds onto it. Total of 3 CC bonds. And if the X is attached to that carbon, that tertiary carbon, we call this halide as tertiary halide. Similarly, in the case of alcohol, instead of X, if it has alcohol there, so you imagine that X is not there, I have alcohol, then it is called a primary alcohol. And here if OH is there, then it is called secondary alcohol, and here also OH, then it is called tertiary alcohol. So now the question is, what will be the order of reactivity? Which among this alcohol is more reactive towards a hydrohalic acid? For that, but we will not see the reasons specifically. We will just try to follow the order. So tertiary is much highly reactive than secondary, which is again much highly reactive than tertiary. So tertiary alcohols are highly reactive. Then comes secondary, and then come the primary. So tertiary alcohol is highly reactive, means its reaction takes place immediately. Secondary alcohol at a moderately faster are moderately fast reactive, means its reaction will take hours or 1 or 2 hours minimum, and primary alcohols are very slow in their reaction. Maybe it will take a day or two to give the product. So the order of the reactivity is that the tertiary alcohol is highly reactive. So in the case of HCl, so we have seen when you are adding HCl, by simply adding HCl the reaction will not happen. In the preparation we have already seen that നമ്മൾ HCl വെറുതെ add ചെയ്ത് കൊടുത്താൽ reaction will not take place. For that what we have to do, I have to add concentrated HCl and heat, or I have to add concentrated HCl and catalyst. This is what we have seen, isn't it? So I will write it down to recollect it. So for in the case of concentrated HCl, I have to add not just concentrated HCl, either I have to heat the mixture or I have to add zinc chloride as the catalyst, Lucas reagent. So I have to do this, isn't it? But in the case of tertiary alcohol, you don't have to do heating, neither heating nor zinc chloride. You should not add zinc chloride. You just add concentrated HCl. It is so reactive that it will react with concentrated HCl, whereas secondary and primary will not react with concentrated HCl. It need either heat or zinc chloride. Clear? So tertiary alcohol can react with concentrated HCl without heating or without using zinc chloride. So that's a clear-cut evidence that tertiary alcohol is highly reactive. Now this difference in the reactivity is utilized. This difference in the reactivity is utilized to identify primary, secondary, and tertiary alcohol from a given sample. So this difference in the reactivity, primary is highly reactive, secondary is moderately reactive, and primary is highly reactive. This difference in the reactivity towards which acid? Hydrohalic acid. So with hydrohalic acid, tertiary is very fast, secondary is moderate, and primary is very slow. So we have utilized this in order to identify or in order to classify primary, secondary, and tertiary alcohol. So that's the question here. Give a test to identify the degree of the given alcohol, whether it is primary, secondary, in a given sample. So I need to conduct a test. So the result will be, must show or must differentiate primary, secondary, and tertiary alcohols in a given sample. So degree of alcohol can be identified using Lucas reagent test. Lucas reagent test. On adding Lucas reagent, what is Lucas reagent? We have already learned concentrated HCl plus catalyst, that is zinc chloride. On adding concentrated HCl and zinc chloride, if the given alcohol is tertiary, if the okay, they have started here with primary, so there will be no turbidity if the alcohol is primary. So we have already seen in the previous slide, primary is the will show the slowest reaction. Primary alcohol will show the slowest reaction. So since it is very slow, there will be no turbidity on adding this Lucas reagent into primary alcohol. Whereas if you are adding into secondary alcohol, in the case of secondary alcohol, turbidity appears after some time. So if there is no turbidity even after some time, that means that it is primary alcohol. If there is turbidity appearing after some time, then it is secondary alcohol. Or if you are adding Lucas reagent, tertiary alcohol shows instant turbidity. അപ്പം തന്നെ നമുക്ക് എന്ത് കിട്ടും? Turbidity കിട്ടും. Instantaneously you will get the turbidity. Clear? Now the next question is, why is it turbid? What causes turbidity? Turbidity is due to the formation of Rx. Rx is actually insoluble in water. Clear? So again we will repeat. HX, what I have given here, HCl, constant HCl, the reactivity of constant HCl is different for primary, secondary and tertiary. Tertiary is very fast, secondary is very slow. So I will write it here, the reaction RCl with concentrated HCl plus zinc chloride will give, sorry, it's not RCl, ROH will give RX, isn't it? With concentrated HCl and zinc chloride, what you will get is RX. Now this RX that is obtained is insoluble in water. Insoluble in water. So if we are carrying out a reaction, how to determine whether the product is formed? You just see the turbidity. If RX is formed, it will be insoluble and it will be turbid. So for primary alcohol, the reaction is very slow, so you will never see turbidity. Even if you are standing there for a couple of hours, you will not see turbidity. If that is the case, then alcohol is primary, because RX will not be formed. In the case of secondary alcohol, this is formed slowly, so after some time the solution appears turbid. Whereas in the case of tertiary alcohol, immediately you add, you will get RX and the solution turns turbidity. Clear? So before finishing this part, let us wind up, let us conclude the reactions that we saw in this part. So I have alcohol, and from alcohol how to synthesize haloalkanes. Either, so in the case of chloroalkanes, here it is chloroalkanes, I can synthesize by passing HCl gas, or I can synthesize using constant HCl. You have to heat it, or I can use constant HCl. Instead of heating, I can use zinc chloride. So that is Lucas reagent. Clear? Now in the case of bromoalkanes, either I can heat with 48% HBr, or I can heat with NaBr and H2SO4, salt and H2SO4. So H2SO4 will produce HBr from it. Always HBr or hydrohalic acid is required for this replacement of OH to Br or OH to Cl. Next is using to synthesize iodoalkane. So you have to use potassium iodide or sodium iodide salt along with 95% orthophosphoric acid. So you can use this, and we have learned why we cannot use H2SO4. So one thing is missing is fluoroalkanes, which we cannot synthesize directly, and we have learned the reason for that, isn't it? But we can synthesize fluoroalkane from either of these haloalkanes, either from bromoalkane or chloroalkane. I can synthesize fluoroalkanes. So I cannot do it directly from alcohols, but I can do it indirectly from alcohols. How? From alcohols, first I synthesize either chlorine or bromine, and from chlorine or bromine I can synthesize fluorine. That's called halogen exchange. That also we will study among the synthesis of haloalkanes. Clear? So in this part we have seen about hydrohalic acid. In the next part we will see about phosphorus halides and thionyl chloride. So until then, see you.